Hello, this is Eric from UNC Charlotte. I'd like to present my perspectives on the state of PDC adoption in early CS courses. These are perspectives that I have formed over the years through my collaboration with Kier Subramanian and Jamie Payton. The short version of this talk is that we need to communicate more as a community to synchronize our efforts in making high-quality materials available. We don't necessarily need to work harder to get PDC adoption, but we definitely need to work smarter. And to do that, we will need to work together. Over the last 20 years, we have seen the rise of multi-core systems as primary computing devices. GPUs are in all consumer computers, and most applications are widely distributed over the internet. But our education of computer scientists has not really followed suit. We still mostly teach students how to program sequentially, often relegating parallel and distributed topics to upper division electives. To remedy that, the CEDAR group developed in 2012 a PDC curriculum recommendation. In 2013, PDC topics were included by IEEE and ACM in their curriculum guidelines. Despite curriculum recommendations, we have not seen wide adoption of PDC. The reasons can be diced in 10 different ways, but it boils down to the difficulty of changing local curriculum, especially when so few instructors have PDC skills, but also PDC class content to put in their courses. The community organized training workshops, for instance at 6C and during summer, that provided training to hundreds of potential instructors. In some CEDAR discussion, a phrase that kept coming back is that materials that can be directly used to teach PDC are the puppies. Curriculum guideline and training are great, but give them puppies, give them materials, and now people get excited. So, what makes for good class content for PDC adoption? Actually, it's the same thing that makes good class content for any topic to be adopted. First, a courseware should cover a technical topic at some level of depth. And that's what we usually think of when we think of a good courseware. But also, a courseware should engage students with the content, because there is only so long students can absorb abstract technical content. Having content that students want to engage with will help motivate students. Materials should justify why the techniques presented are needed. This is in particular important when talking about performance. Students see computers as infinitely fast, so dropping a calculation from 30 milliseconds to 5 milliseconds will not convince them that they need to care. Courseware also need to address the level of expertise of the instructor. Most likely, instructors will not be PDC experts or experts in the applications and examples that the courseware mentions. A good courseware needs to seamlessly integrate in a class. Class time and instructor time are limited, so ideally, instructors won't drop in content. If a courseware uses a different language than the class, or if it requires a particular environment that will need to be configured, then using the material will require lengthy, distracting side notes. Courseware need to enable building a curriculum by making a comprehensive class that is internally coherent and consistent with previous and follow-on courses. Finally, and maybe most importantly, this courseware need to be discoverable. If you have the best courseware, but no one can find it, it will not be very useful. The paper contains a review of multiple resources from the community. Let's look at a couple of examples to see how the framework applies to them. CS in Parallel is a collection of modules to teach parallel computing at various levels. It organizes the materials based on course, language, and technology for easy search. Modules provide summaries, learning goals, and context for use. Some modules come with notes to help instructor pick up the module, though most do not. The content is detailed and makes little assumptions. This is a great resource to help teach a variety of PDC topics. Unfortunately, the modules provide little motivation, interesting application, social contextualization, or broader engagement strategies. The collection is also pretty sparse. making it unlikely to help build a panel of engaging content for a wide variety of classes. EduRange is a set of self-paced modules to teach many PDC concepts. The content is made of textual descriptions, and the activities rely on observing demos using SimGrid as a simulator, and which are deployed as Docker containers to be runnable on any student machine. This is great content to teach fundamental PDC concepts, even though it lacks teaching their practical use. But EduRange completely relies on external motivation for the students and does not provide instructor material, contextualization, or practical assignments. It quickly becomes obvious that there is no golden nugget, the perfect module that is technically competent, that connects with your students where they are, that is easy to adopt based on what you know, and that can be executed with technologies used in your class. We don't have a perfect module that hits all the marks, but we have great content out there developed by experts in the field. So, we should be able to form modules by composition. We can pick motivational applications and demos with low technical content, use general conceptual descriptions, lectures, and activities, pair them with practical content and a panel of assignments designed to engage different populations of students. Now, to make that happen, we will need, as a community, to make many engaging courseware, and we will need to make them easy to find. Engagement of students by providing real-world applications and justifications for the techniques is one of the hardest property to provide. With the multimediaization of the world and increase in computer performance, engaging students on performance issues has gotten harder. That problem is actually shared by instructors who teach data structure and algorithm. We have developed an approach in this context that could apply to PDC. Bridges brings real-world datasets and applications to the classroom. By scaffolding the input and output of programs, the students can focus on the technical aspects while gaining contextualization of an application. Importing real-world datasets enables to work on problem sizes where using an algorithm of improper complexity will not be practical. Bridges can be used to create a panel of assignments where each stress the same topics and learning outcome, but the different assignments can provide different dressing for the problems in order to bring relevance to different groups of students. Curating and indexing materials is a complex task, and we need as a community to agree on how and where we will do that indexing. Though, it turns out that we've done the hard part. We have developed a list of topics and learning outcomes. We call them curriculum guidelines. What remains to do is to put all our materials in one system, and we have developed CS materials especially for that purpose. It enables you to add materials in the system by classifying them against curriculum guidelines. Then, these materials can be retrieved by explicit search and inexact search. Provided instructors put their entire course in the system, we can also build class profiles, which can help us identify missing materials that could be integrated in early CS courses. Developing materials to serve a wide range of students and courses will be critical to our PDC adoption efforts. And we will need to curate and index this courseware, because if instructors can't find them, they're no good to us. What I know is that I can't do this, and you probably can't do it either. We will have to organize and do it collectively. Is CS materials the curation system we need? Maybe not, but let's figure out what we need and pool our efforts together. Let's index our courses, whether they have PDC content or not. And let's make sure that our PDC content is in a single place so that we can easily find what is relevant to particular instructors whenever they come to us. Development, indexing, and curation of PDC educational content is why we need a community effort to achieve PDC adoption. Together, we can make it happen.